Welcome back to the virtual classroom of Chem-based School of Chemistry. Sound clear? Right, we'll begin the discussion on Redox. In fact, we just started the Redox chemistry last week. I explained about what is reduction, oxidation, and then we had a discussion on the explanation, a definition of reduction, oxidation in terms of oxidation number, in terms of oxygen, hydrogen, and as well as in terms of the electrons. You should be able to define the reduction, oxidation in all these different types of definitions, and able to identify the redox reactions. Reactions where reduction, or both reduction and oxidation takes place, are referred to as redox reactions. And in a redox reaction, you need to know how to identify the oxidizing agent as well as the reducing agent. Before that, I explained the 8 or 9 rules of assigning oxidation numbers, because not always you get to define redox reactions in terms of oxygen and hydrogen. Sometimes you get to define in terms of oxidation. So therefore, we need to know how to assign the oxidation number of element. There are a few rules. Just to summarize the rules again, the oxidation number, because today's lesson, you need to know these rules. The oxidation number of an atom in an uncombined element is 0. That means if you have a uncombined element like in this equation, copper or carbon, or here sulfur, right? They are uncombined state. The oxidation number is 0, and also oxidation number of a diatomic molecule is 0. You can see some diatomic molecules here. Hydrogen is diatomic, and then oxygen, chlorine, and iodine, they are diatomic molecules. So oxidation number of a diatomic molecule is 0, and certain elements, the oxidation numbers are fixed. For example, group 1, all the elements, the oxidation numbers of group 1 elements is +1. The group 2 is always +2, and fluorine, even though the group 7 shows multi-oxidation states, the fluorine being the most electronegative element will show the oxidation state -1. And the oxidation number of a simple ion is the charge on the ion. And the most important rule being the sum of the oxidation numbers of a neutral compound equals 0, which means if you add the oxidation numbers together, that will be 0. Say magnesium is +2 and oxygen is -2. +2 and -2 is 0. And oxidation number of a charged species, sum of the oxidation number of a charged species is equal to its charge. So that is useful for us to find the oxidation number unknown element. Say, for example, sulfur has more than one oxidation state. In sulfate, it's +6. In sulfite, is +5. So the sum equals to its charge, right? So that is an important rule. And also the more electronegative element, always when you have 2 elements, you should need to know which one has a negative and which one has a positive oxidation state. The one with a more electronegativity, great electronegativity, is given the negative oxidation state, and the one which has a less electronegativity is a positive oxidation state. And hydrogen is always 1, and hydrogen also has oxidation state of -1, where we call the hydrogen -1 ion as the hydride ion, and hydrogen +1 is the hydrogen ion. So whenever hydrogen is combined to a less electronegative element than hydrogen itself, when hydrogen is combined with a less electronegative element than hydrogen itself, then hydrogen will be negative. In that case, it will be called as the hydride ion, the -1 oxidation state. And as for the oxygen is -2, and I explained last week there are different types of oxides. The normal oxide is -2, the peroxide is -1, and when you combine with fluorine, it will take a minus. So these rules are important to analyze the oxidation state of various compounds, and we named certain molecules and ions with respect to these oxidation states, and also I explained about the oxidizing agents and reducing agents, how oxidizing and reducing power varies down the metal group and the non-metal group. And at last, our discussion was on the disproportionation reaction. I explained what a disproportionation reaction is and the difference between the redox reaction and disproportionation reaction. There's a difference. Disproportionation reactions are not redox reactions. The reason redox reactions, one species is oxidized, whereas the other species is reduced. Whereas in a disproportionation reaction, there is simultaneous reduction and oxidation taking place in the same species, in the same reaction. So that's simultaneous reduction oxidation, so therefore it is not redox. So that means one particular species at the same time, the same equation reduce as well as oxidize. For example, chlorine here, +1 to -1 decrease in oxidation state, that is reduction, and +1 to +5 is the increase in oxidation state, which is oxidation. So this is simultaneous reduction and oxidation of the same species in the same reaction is referred to as a disproportionation reaction. I think this is where we stopped in the last session. To continue and complete the rest of the lesson, let's see how to balance the ionic half equations or the ionic equations with the help of oxidation and reduction half equations. You can see this particular ionic equation. This is ionic equation because ions are involved in the equation, and we discussed under the chapter 1, which is the chemical calculation chapter. I explained there regarding the ionic equations, how to derive ionic equations. So once you have ionic equation, how do you balance it? Now you can balance ionic equations with the help of writing the reduction and oxidation half equation and analyzing the elements and the charges in those half equations. Remember, whenever it comes to ionic equation, balancing ionic equation involves balancing with respect to elements as well as charge. It's not just balancing the charge. You have to balance the elements first and then the charge as well. So let's look at this first example. You can see copper, which is zero oxidation state here because it's uncombined state. So copper zero oxidation state has increased its oxidation number to +2. So we know increase in oxidation number is defined as oxidation, whereas silver iron has decreased its oxidation state from +1 to 0. So that is reduction. So what you need to do is, first of all, identify which species is reduced and which species is oxidized. So first you write the reduction. So Ag plus has reduced to Ag. And once you write the reduction half equation, you balance it with respect to the elements. It's already balanced. With respect to the charge, I just simply add an electron onto the silver ion side to balance the charge, because on the right side there's zero charge, on the left side plus and minus is 0. The charges are now balanced by simply adding an electron onto the reactant side. So this is a reduction. Reduction is gaining electron. Reduction is gaining electron. Oxidation is loss of electron. So it's always advisable to add an electron onto the left side than writing minus electron on the right side, which is not wrong, but always is better to write reduction as gaining of electrons. And then the oxidation half equation, Cu turn to Cu2 plus is oxidation, and you have to add 2 electrons because oxidation is loss of electrons onto the right side. And then you add to both the half equations to construct the overall equation. Now, when you do this, it's very important that the overall equation should not carry any charge, which means when you're adding the two half equations, you need to ensure that the electrons get cancelled. So therefore, you have to equalize the electrons. In order to equalize the electrons, what we can do is you can multiply the entire reduction half equation by 2. When you multiply the entire half equation by 2, you equalize electrons. You have 2 electrons on the left side and the 2 electrons on the right side. So now you simply can add the two half equations and balance it. You can notice at the end overall equation, you have 2 silver, right? And 2 silver. Silver is balanced, copper is balanced. In terms of elements, it's balanced. In terms of charge, on the left side, there's 2 plus charge. On the right side, there's 2 charge. Charges are also balanced in this half equation. The overall redox balance equation is this. So this is how we construct the overall redox balance ionic equations with the help of the construction of the reduction and oxidation half equations, right? I hope it's clear. You can copy this. If you have any questions, you can clarify. If not, you can copy and try. There are 3 more questions to complete. So you can try the 3 questions now after copying this. There's a question, when we write ionic equations, should we first write what is oxidized and then what is reduced? There's no such order. You can write the reduction half equation first and the oxidation, or you can write the oxidation first and the reduction first. It doesn't matter. Right, so you can, I will also parallelly do with you, then you can check whether you got your answers correct. I'm going to write the reduction first. That doesn't mean when you write oxidation is wrong, both ways is correct. So 2H plus 2 electrons, hydrogen, gaining electrons in oxidation. Zinc, right? Zinc, zinc 2 plus 2 electron. In this case, there's nothing to multiply with, right? Nothing to multiply with. Electrons are equal. 2H plus zinc being hydrogen plus zinc 2 plus. You can check your answers. The second equation, the electrons are already equal, the charges are already equal, so nothing to multiply with. Reduction half equation, Cl2 to 2Cl minus plus 2 electrons. Multiply this equation by 2 to equalize electrons, and then you add. So you can analyze the last redox equation here. It is balanced with respect to elements as well as the charges. You can see the chlorine is already balanced, 2 chlorine, 2 chlorines, 2 cobalt, 2 cobalt. But as for the charges on the left side, you have 2 plus charge here, and the right side there's 6 plus and 2 minus is 4 plus. So the left side you have 4 plus charge, as well as the right side you got the 4 plus charge, because 3 times 2 is 6, 6 plus and 2 minus is 4 plus, and here it's 4 plus, right? Have you done the last one? So first you balance the oxidation half or reduction half equation and then oxidation, but there's no such order. You can check the last question. I'm going to first write the reduction. You can also write the oxidation first. So what is reduced is iron here, ferric to ferrous. And what is oxidized is tin 2 plus to tin 4 plus, 2 electrons. And you multiply this equation by 2, right? Because to equalize electrons, you multiply the first equation by 2, because overall redox equation should not carry any charge. I mean, should not carry any electrons, right? So it's Fe 2 Fe3 plus tin 2 plus, giving 2 Fe 2 plus tin 4 plus. You can look at the charges. Iron, 2 iron, tin. Elements are balanced. As for the charges, iron here is 6 plus and 2 plus is 8 plus, and here 2 times 2 4 plus and 4 plus is 8 plus. So the charges are balanced as well as the elements. Clear? Any questions?